Hey everybody, today I'm doing another math problem, and we are doing the same thing on 4.3, which is this section is called homogeneous linear equation with constant coefficients. Okay, and before I continue doing this, I want to apologize for the misspelling that I had in the last video. I realized that I had misspelled homogeneous and linear and also equations, but it was too late. The video has been already filmed, and I decided to upload it that way because when I watched the video, pretty much the only major error was the misspelling in the procedure for the differential to solve the differential equation was not too bad. So, and I thought that if a student want to learn mathematics, they can actually it does. It's not really matter if I misspell something, because if I misspell something, but as long as you guys learn the mathematics, that is our main purpose. But anyway, I still apologize because it was my fault. I usually catch it quick, but I didn't catch it this time. So, and I decided to upload it that way. But again, I want to apologize for my spelling errors. So, okay, so I'm going to go through the steps again, kind of quick. We will do the steps. In step 1, we consider all the cases, right? So, on the last problem that I did, I had case 1 to find the complementary solution, okay, which as long as you know the rules, it doesn't matter in what order you actually put this. But in this case, what I did, I said consider all the three cases. Okay, so all three cases, okay? So case 1 is a distance root. Okay, distance root means that M1 cannot equal M2. Okay, so in other words, the root they have to be different for case 1. In case 1, the complementary solution is going to look like this. Y is equal to C1 e to the m1x plus C2 e to the m2x, right? Case 2. On case 2, m1 equal m2, okay? So in this case, m1 is equal m2, therefore the root will be the same. Again, the root will be the same. And this means that if m equal 2, m1 equal 2, m2 has to equal 2. But if m1 is equal to negative 2 and m2 is equal to 2, then the roots are not the same. They have to be equal as the value and also the sign. Okay, so they have to be equal. Now, the solution, the complementary solution, is going to be as follows: y equals C1 e to the m1 x1 plus C2 times x e to the m2 x2, right? So the only difference between case 1 and case 2 is that we add an x in front between C2 and E, okay? So now case 3 we have a conjugate complex root, okay? Conjugate complex root, that means that we will have imaginary roots, okay? Now in this case we know that if we have imaginary root, the answer is going to give the complementary solution is going to be in a trigonometric form. So therefore we follow the Euler's formula. The Euler's formula says e to the I theta equal cosine theta plus sine theta, right? When theta is any real number, okay? Now, what we can do is we can actually transform this formula, and instead of having theta, so we can have a beta x, right? So the formula can be transformed from this one to this one, which it is e to the I beta x equal cosine beta x plus I sine beta x, right? And the other one is e to the negative I beta x equal cosine beta x minus I sine beta x, right? And then, so this is step 1, okay? So in step 2, we find the complementary solution, right? And in step 3, we find C1 and C2 and substitute the values of C1 and C2 into the solution, into the complementary solution, and that will be our final answer. So the complementary solution is very important because the complementary solution is part of the process to get the final answer. Okay, so I am going to erase this, and I am going to do one problem. So we are going to do one problem, and that problem is going to be number 34, okay, number 34. But before I am going to write what we're doing, because it's important too to know what we're doing. We're solving initial value problems. We're solving initial value problems. Okay, so that is what we're doing. Okay? So I'm going to do number 34. Okay? Number 34 is as follows. Number 34. Okay? And remember, we're still working in this section on 3.3 in this book, the same book, our first course in differential equations with modeling applications, 10th edition by Dennis G. Seal. Okay? So 34 is equal to y double prime. Okay? I'm sorry, the problem is I say 34 equal to, I'm sorry about that too, I shouldn't say that, okay, so So number 34 is y double prime, sorry, minus 2y prime plus y equal 0. And the initial conditions are y at 0 equal to 5 and y prime of 0 is equal to 10. Okay. So we are going to do this problem, okay, and see what we get. Okay. So step one, I need to follow the procedure to find the roots, right? And I forgot to write the formula. Okay, the formula is a m squared plus b m plus c equal 0. Okay. So in other words, you gotta have, in order to this apply, you gotta have a homogeneous, which is what we do in homogeneous, which in this case, this equation right here, this differential equation is already on a homogeneous case, right? We have it equal to 0. So I am going to use this formula to find the roots, right? What I'm going to do, I'm going to replace everywhere that I have a derivative, I'm going to replace by m, okay? In this case, I have this is linear homogeneous differential equation, second order, right? So I'm going to say that m squared minus 2m plus 1 equals 0. Right? All I did was I took the m, I took the derivative and replaced it with m, and over here, because I didn't have the derivative on the plus y, but I have a coefficient of 1 in front of it, I just substitute with 1. Now I'm going to factor this out and see what I get. If I factor this, I can get m minus 1 times m minus 1 equals 0, right? Let's see if this is correct, okay? So m times m squared, m times a negative 1 is negative m times 1 times a negative m is negative m, and negative 1 times negative 1 is plus 1 is equal 0, right? If I substitute if I add this 2m right here, what I get m squared minus 2m plus 1 equals 0, we checked. Okay, so that is the right factoring. So because it's the right factoring, that mean that I can actually find m1 and m2 now. So let's do m equals m minus 1 equals 0 and m minus 1 equals 0. So m is equal to 1, m1 is equal to 1, m2 is equal to 1. Okay? So that means that we are in case we are in case number 2. Okay, we are in case number 2. Why? Because m1 equal m2, right? So in this case, the solution, the complementary solution, is going to be y equal C1 e to the x, right? Because I am putting, because they both positive, okay? So I just writing x. Technically, it is 1 in front of the x right there, okay? So plus C2 e to the 1 times x, right? So this is the complementary solution. Okay? Now, I'm sorry, I'm missing something. I just realized that I'm in case 2. So e to the 1 times x. Okay. So notice that this is the complementary solution. Now what I'm going to do is m1 is equal to 1, m2 is equal to 1. Let me erase this. Okay. So now I'm going to use the initial value given, okay, the initial conditions, okay, the initial conditions are this, okay, at y, the regular function evaluated, which is this function, okay, evaluated at 0 is equal to 5, and then the derivative evaluated at 0 is equal to 10. So what I'm going to do, I'm going to take the derivative of this, right? When I take the derivative of this, what do I get? I get y prime, okay, equal C1 e to the x, right, plus C2, and I'm going to put the parentheses right here, okay, because in this case I'm going to use the product rule to find the derivative of this piece right here, okay, because remember that I have an x multiplying e to the x, so I need to do the product rule. So I am keeping the C2 outside the parentheses, and I'm going to take the derivative of the first times the second plus the derivative of the second times the first, okay? The derivative of the first times the second plus the derivative of the second times the first. So the derivative of the first is 1, right, times e to the x is just e to the x, okay? The derivative of the, and then plus, okay, the derivative of the second times the first, right? So the derivative of e to the x is just e to the x, okay? So it's e to the x, okay, times x, right? So e to the x times x. So times e to the x, okay? Okay, so that is the derivative. Okay, now I am going to substitute the initial conditions given, right? So the initial condition for this one right here is going to be, I'm going to substitute 5 for y, and I get 5 is equal to C1, okay, times e times e to the 0 plus C2 times 0, okay, times e to the 0, okay. So now notice e to the 0 is 1 times 0 is 0, right? So this is 0. And this is nothing but 5 is equal to C1, right? So I know that C1 is equal to 5. Okay? So C1 is equal to 5. Now, let's see if I can find C2. Okay? So, notice that I already have a C1 is equal to 5. Let's see if I can find C2. Okay? So I know that y prime is equal to, evaluated as 0, okay, y prime evaluated as 0 is equal to 10. So I plug in, for y prime, I plug in 10, okay, equal this right here, okay, this is the one that I'm using right now. This is the derivative, okay? So, and I know that C1 is 5, so 5 times e to the 0 plus C2 plus C2 times e to the 0 plus 0 times e to the 0, right? Well, in this case, notice that 10 is equal to e to the 0 is 1 times 5 is 5, right? Then, right here, I got 0, okay, so e to the 0 is 1 times 0 is 0. So I will have just plus C2. If I multiply C2 times 0 is 0, so I'm not going to bother multiplying it. I am just going to go ahead and multiply. E to the 0 power is 1 times C2 is C2, right? So then what I'm going to do is minus 5 on both sides, minus 5 on both sides, and I get that C2 is equal to 5. Okay? So C2 is equal to 5. Now that I have this, I can actually go ahead and plug these values into this, okay, because this is a complementary solution, right? So what I'm going to do, I'm going to rewrite this. Let me just erase this, okay, so I can have the answer right there. And the final solution is going to be y equal 5, right? Because C1 is 5, right? Plus times e to the x plus 5 times x, right? E to the x. E to the x. That is the answer, okay? So, again, the process is not that difficult. It just requires a little focusing of what we're doing, and that's it. I hope this helped. And again, my purpose is to helping those who are doing differential equations, right? So, I'm sorry about, misspelling stuff. But as long as you get something out of this, that's it. I mean, that's the whole purpose of it, to learn the technique how to solve these problems, because the other stuff you can always improve later. But the main thing is to learn the steps how to solve this type of problems. All right. Thank you for watching. All right.